Okay, here's the video for page 6. This is probably the last one I'm going to be able to do today without my hand falling off. So here we go. Find the area of the sector described in each situation. Now, area of a sector is given by even another equation. But you'll notice what they gave us here. They gave us S, which means we're going to be using that arc length equation again, S equals R theta. We're going to be using that to find theta. Then we're going to turn around and use the area of a sector equation, which is 1/2 theta R squared. The area of a sector in a circle is 1/2 times the central angle in radians times the radius squared. So these are two-step problems. We're going to start off finding theta. So step 1, we're going to find theta. And we're going to do that using the equation S equals R theta, just like we did in the previous section. So S equals R theta would be pi equals 2 theta. We divide by 2 to get theta by itself, and that gives us that theta is pi over 2. That is the first step, but we're not done. Okay? Then we're going to find the area of the sector, which is 1/2 theta R squared. So that would be 1/2 times pi over 2 times the radius, which is 2, squared. Feed that to the calculator. That ends up being pi units squared. Again, you should pause this video and try the next couple on your own. Alright, so on the next one here, S equals R theta, which means 5 pi equals 3 theta. Divide by 3. Theta is 5 pi over 3. Okay, we're solving for theta. Then we turn around and we find the area of the sector. So area equals 1/2 theta R squared. That would be 1/2 times 5 pi over 3 times R, which is 3, squared. Feed it to the calculator. 3 would cancel. It gives us 15 pi over 2 units squared. It's an area, so it's in units squared. 47, S equals R theta would be 3 pi equals 8 theta. Divide by 8, theta is 3 pi over 8. Then we turn around and we say area is 1/2 theta R squared. That is 1/2 times 3 pi over 8 times 8 squared. Multiply that out, that would be 12 pi. Let's double check that real quick. Yep, 12 pi units squared. And finally, S equals R theta, 2 pi equals 4 theta. Divide by 4, and we get theta is pi over 2, because that reduces. Then the area is 1/2 theta R squared. That is 1/2 times pi over 2 times 4 squared. Multiply that out, that would be 4 pi units squared. Should take care of that section. Next section. If the computer ever changes. There it goes. Find the measure of the central angle in each situation. Now notice what they've given us. They've given us A and R, which means we're going to be using the area equation. Area equals 1/2 theta R squared, because we know everything in that equation except for theta, which is what we're being asked to find. So on each one of these problems, we're going to plug into 1/2 theta R squared. So 4 pi equals 1/2 theta times 3 squared. And we're going to solve for theta. So the first thing we're going to do is multiply each side by 2, which will cancel the 1/2. We're also going to go ahead and do 3 squared at the same time. So that would be 8 pi equals 9 theta, and then divide by 9, which would give us our answer. Theta is 8 pi over 9 radians. Let's do one more before I suggest that you pause it. Area equals 1/2 theta r squared. So that's 6 pi equals 1/2 theta times 4 squared. That would be 12 pi, because I'd multiply each side by 2, equals 16 theta. Divide by 16. And reduce. 12 pi over 16, each are divisible by 4. That would be 3 pi over 4 radians. Should pause the video and try the others on your own. Area equals 1/2 theta r squared. So 3 pi equals 1/2 theta times 4 squared. Multiply each side by 2. And go ahead and do 4 squared, which is 16. So 6 pi equals 16 theta. And then divide by 16. Reduce the fraction. Theta equals 3 pi over 8. And again, that measurement is in radians. I'm going to go ahead and leave out the equation from this point forward. Again, we're doing A equals 1/2 theta r squared. Multiply each side by 2, so 10 pi. And do the squared, which would be 100. Divide by 100. And reduce. Theta equals pi over 10 radians. 6 pi equals 1/2 theta times r squared, which would be 3 squared. Multiply each side by 2. Would give us 12 pi equals 9 theta, because 3 squared is 9. Divide by 9 and reduce. Theta equals 4 pi over 3 radians. And finally, 8 pi equals 1/2 theta times r squared, which would be 3 squared. Multiply each side by 2 and square the radius. Divide by 9. That does not reduce. So theta would be 16 pi over 9. I don't know why I wrote that in black. It bothers me, so I'm going to change it. If it'll let me. Anytime there, computer. No, it's not going to let me. Guess we're going to leave it. Okay. Now that brings us to the bottom problem on page 6. Now the bottom problem on page 6 is from sections 7.1 to 7.3. So chapter 7, sections 1, 2, and 3, dealing with the law of sines and the law of cosines. Which again, those are your notes for sections 7-1, 7-2, and 7-3. There are also examples in your textbook if you'd like them. So we need to draw a picture. So we have a triangle. It doesn't matter if your picture is perfect or not. It really doesn't matter at all. We have 3 angles A, B, and C listed with capital letters, and 3 opposite sides with lowercase letters. So little c, which is 326 feet, is known. We do not know the length of little a. We do not know the length of little b. We do know that angle A is 111 degrees, and we know that angle B is 41.0 degrees. Now notice we're far enough into the book now that significant figures matter, and all 3 of these numbers are listed with 3 significant figures, which means all of our answers should be rounded to 3 significant figures. We need to find 3 measurements to end this problem. The measure of angle C, the length of side marked little a, length of side marked little b. So make yourself a little answer box up in the upper right of the workspace and put your answers up there. Now this is we're given side angle side information. Anytime you are given side angle side, I'm sorry, not side angle side, angle side angle, that was again an example of me being tired and still trying to do these solution manuals. We're given angle side angle. That's the information that we know. So we know angle side angle. That makes this a 7-1 problem, and we are using the law of sines. Not even the ambiguous case, just the law of sines. So what we need to do is a three-step process. Step 1 is find the measure of angle C. Remember that one way that we can do that is the angles add to 180. So the measure of angle C is 180 minus the two known angles, 111 and 41. So 180 minus 111 minus 41 would be 28 degrees, which we would write as 28.0 degrees because that would be the appropriate number of significant figures for this problem. So there's one of our three answers right there. Again, that's step 1. Find the measure of angle C. Okay, then we're going to do the law of sines. So step 2, it doesn't matter which one we find next, so let's go alphabetically. We're going to find the measure of little a. The length of little a is found using the law of sines, which is on your reference sheet, although it will list all three of the ratios. You only use 2 at a time. So since we know both little c and angle c, we are going to set up the law of sines where little a over sine a of angle a equals little c over the sine of angle c. The reason we're doing this is because now that we've figured out that angle c is 28 degrees, we know one set of information, so we're going to use that set to find everything else. So we plug in, that would be little a over the sine of 111 degrees equals 326, which is little c, over the sine of 28 degrees, which is big C, angle C. That's a proportion. Everybody knows that when you solve a proportion, you are cross-multiplying. So we cross-multiply, which gives us a times the sine of 28 degrees equals 326 times the sine of 111 degrees. You should not be reaching for your calculator until you have finished solving for the variable. So when we're looking there, we have a times the sine of 28 degrees. To finish solving for a, we should divide by the sine of 28 degrees. So what we're going to do is we're going to feed this fraction to the calculator. And that will tell us that a, and we're going to round to 3 significant digits, 326 times the sine of 111 divided by the sine of 28 is 648.2, so 648 feet. Finally, step 3, and I'm actually going to use some of this space over here. We're going to find little b. We're going to use a very similar approach. B over the sine of angle B equals little c over the sine of angle C. Same exact work as before. Little b divided by the sine of 41 degrees. That looks like a 91, so I'm going to fix that. Anytime, computer. There we go. 41 degrees equals 326 divided by the sine of 28 degrees. We're going to do the exact same work. We're going to cross multiply, which would give us b times the sine of 28 degrees equals 326 times the sine of 41 degrees. And then we're going to divide by the sine of 28 degrees. Which we will then feed to the calculator. So 326 times the sine of 41 degrees divided by the sine of 28 degrees. And we're going to round that to the nearest, or to 3 significant figures. It's 455.5, so that would round up to 456 feet. Again, we're solving the triangle, which means we're finding everything that we don't know. So we need to find all 3 measurements that we don't know. You either need to circle your answers, you need to write them on the actual triangle, but they have to be readable, or you need to write yourself an answer box in the upper right like I did, so that all 3 of your answers are obvious. There are several more of these on the next page, but I am not doing any more of these videos tonight. So that's a good start. We got the first 6 pages